focus on the ethicality of genetic testing as well as discrimination in individuals at risk for Huntington's disease. So we started talking about Huntington's disease in class, and basically, just to retouch it real quick, it's a fatal hereditary degenerative disorder of the central nervous system, where it degenerates and damages nerve cells in the brain, which eventually causes mental and physical atrophy that affects cognitive, motor, as well as psychiatric effects throughout your body. There is currently no cure or treatment to slow the progression of Huntington's disease, and typically the demise or death of a patient is caused from other medical complications, such as pneumonia, heart failure, other issues like that. So there are two main types of Huntington's disease. There's adult and juvenile Huntington's disease. Symptoms typically begin for adults between their 30s and 50s, and it takes about 10 to 15 years for the disease to really take over. And then for juvenile Huntington's disease, it affects children and adolescents under the age of 20. And it typically progresses more rapidly than adult onset. Currently, there are 30,000 symptomatic Americans and 200,000 at-risk individuals. So as I said before, Huntington's disease is a hereditary degenerative disorder, and specifically it follows an autosomal dominance pattern, which I'll show you with this figure later. Basically, autosomal means that it's a non-sex chromosome, that's where it's located, and you only need one abnormal gene to be affected with Huntington's disease. So in this figure, you see the male here in this lighter blue, and he's gene positive for the abnormal Huntington's gene. So he mates with a gene negative, so she has two normal HTT genes, which I'll talk about later. And you see in their 5 children that they have an affected son, meaning he must have gotten that abnormal HTT gene from his father. And he also mated with a non-abnormal and gave rise to these children down here. And then this is the most prominent case showing that there's 2 regular HTT genes and they both mated together, so there was no chance of getting the Huntington's gene. And each of these individuals have a 50-50 chance of getting the abnormal gene, meaning it doesn't matter how many children they can have 5, they can have 2. Each individual child is mutually exclusive and they each have a 50-50 chance of getting that abnormal Huntington's gene. So everybody is born with this HTT gene, and you can see on this figure where it's located. It's on the short arm of chromosome 4. And as we talked about in class, the the HTT gene is responsible for synthesizing Huntington protein. And it's found throughout many body tissues, but the majority is found in the brain. And we also talked about in class that it currently has an unknown functionality. They believe in studies that it is essential in normal development before birth in the brain, as well as function in nerve cells in the brain with signaling, binding to other proteins, and also to lower apoptosis. So specifically, this gene is made of CAG repeats, and this codes for glutamine. There is a normal, the normal range of the CAG repeats is from 6 to 35, and anything above 35, you are at risk for the Huntington, you're considered at risk for Huntington's disease. And typically with subsequent generations, the CAG repeats actually increase. So here's a figure depicting that. I highlighted it in blue. You can actually have mutations where it increases, which is shown here in this case. And you can have cases where it actually decreases the amount of CAG repeats. But the issue with this is the larger the repetition these CAG repeats are, the earlier you develop your symptoms. And this is shown in juvenile Huntington's disease, where you have 60 repeats or higher. And you can see that in this figure as well. Across the bottom, you have your increase in CAG repeats, and as those increase, the age that you actually develop your symptoms lower. So your abnormal HTT gene, you can actually get a little better visualization here in this figure with your CAG code on repeat, and during transcription, it codes for the glutamine, and you end up with, for normal HTT gene, you end up with 6 to 35 CAG repeats, which are little yellow glutamines. And then for Huntington's, they, like I said before, it's anywhere from 36 and above. So this glutamine chain would be way longer, and they normally just refer to it as polyglutamine. The HTT gene expansion is normally what the abnormal HTT gene is referred to for Huntington's patients. And glutamine is typically involved in basal ganglia function, and in this case for Huntington's disease, abnormal function, which we kind of touched on in class with mechanism of action, where you can have a gain of function or loss of function due to this abnormal gene. Or you can have aggregates formed from it being sticky. And due to the discovery of the location of where the gene was found, this paved way for pre-symptomatic as well as predictive genetic testing for Huntington's disease. So, based off of discoveries and researches, they were able to come up with 2 types of predictive genetic testing to actually confirm Huntington's abnormal protein, and if you will eventually develop this disease. And the first one they came up with was pre-symptomatic gene testing, and they used DNA markers to actually locate but they located these DNA markers on the chromosome to tell if you have the abnormal gene expansion, if it's longer than usual. And they also used your family history, so they would look to see if your parents or grandparents had Huntington's. And then the newest is predictive genetic testing, where they actually scan and karyotype for your Huntington protein or Huntington gene and see if it's the abnormal one with 36 or more CAG repeats. And this is important whenever at-risk individuals are trying to plan a family, get married, or career options, and obviously to relieve any uncertainty that they have. So this can be done by taking a blood sample that analyzes the DNA and codes for this HTT expansion. There are also diagnostic tests that they can use to visualize, and other than looking at your DNA, they can visualize it. So here I have a MRI photo, and figure A, you can see a normal brain with the regular normal size of the caudate nucleus as well as putamen and ventricles. And then figure B, you can see the patient has enlarged ventricles and the shrinkage of the caudate nuclei as well as putamen. Like I said, for individuals at risk for Huntington's disease, they often want to test to see if their offspring will have the gene, which I'll talk about a lot of ethical issues with that afterwards. But the main testing they use, they can do PGD, pre-genetic diagnostic testing, where they do in vitro fertilization and make sure that the implanted egg will not have the HTT expansion. And you can also do this while you're pregnant. You can get, in this bottom photo, chorionic villus biopsy, which is done earlier. It's 10 to 11 weeks during pregnancy. And they actually use a catheter to extract chorionic villi, and they karyotype it to look for this gene expansion. Or they can do amniocentesis, which is a little later in the pregnancy. It's about 14 to 18 weeks. And you can see that in this top figure here, where they actually extract some of the amniotic fluid and get the fetus's DNA and then karyotype it from there. So as I said before, there are a lot of ethical and societal issues that arise from at-risk Huntington disease patients as well as these pre-genetic testing. So tremendous stress on the at-risk individuals because they are uncertain if they have it. They go their whole life and they're worried if they will have this gene expansion and eventually develop Huntington's disease or not. As well as these pre-genetic testing, if you find out you have this expansion, those results can be very devastating to you and your family as well. So these prenatal tests, this increases a lot of health risks for a child, and it can often cause miscarriage. And on the other side of that, abortion exists. So if you find out that your child has this abnormal HTT protein and they will develop Huntington's disease, they can still choose to abort your child. Additionally, there was a lack of communal support just due to ignorance and not really knowing or understanding about Huntington's disease. It can cause isolation of the patient or the at-risk individual because, like some people might think, oh, well, their parents have Huntington's disease, I don't want to mate with them. Not that you really think that, but it could be a subconscious thought. And also a very large one that I chose a study to talk about was discrimination. A lot of these at-risk individuals, in some way, shape, or form, felt some type of discrimination. So this study was the I Respond HD study, and what it really focused on was differences in perception and experience of genetic discrimination across the US, Canada, as well as Australia. So basically, 433 out of the 480 individuals consented to releasing these results. So off of these 433 individuals, at-risk individuals, I broke it up by demographics, so you can just get a gist that the US, most of these results are from the US, and then following with Australia and Canada. And here, this first line are individuals that did not experience discrimination. And then this is the second part is what I really want to focus on. There's 200, which is a little under half that responded. They, at some point in their life, experienced discrimination because they were at risk for Huntington's disease, out of the total 433. So the main results are down here at the bottom, and the largest discrimination that these at-risk individuals experienced were relations or social stigma. So basically, this is where they had felt that people had talked down to them, they had told them not to continue their education, etc. The second one following that was health insurance and life insurance, which you can see up here. And those are very important because if you don't have health insurance or life insurance, that can affect your health of living. And the third one is employment. This one was actually pretty terrible because we all get jobs, you know what I mean? And they were denied jobs. They were either fired, they were denied promotions, and all based off of being at risk. And then the last one was transaction or legal issues, and it talked about being denied housing, so nowhere to live. And it also talked about being denied children in a court custody battle. So that's obviously very devastating. And these results are all based off of individuals who had either the predictive genetic testing or have not, and they're just looking at their family history. So you actually don't know if they have the abnormal Huntington protein. So based off of all these ethical issues, they came up with the HDSA guideline, which is Huntington Disease Society of America, and they wanted to follow these 4 guidelines to kind of support and encompass all of these issues that arose. So the first one was to offer a neurological evaluation, and this is just to really confirm that if the patient is experiencing these symptoms of Huntington's disease. The second is timing. They wanted to make sure that the at-risk individual is at a time of low stress and they are in a supportive environment. And confidentiality, they wanted to make sure that these their medical safety will not be compromised. So it's not going to get out and ruin their career and everything. And then the last one was a companion. They they suggest you to have a supportive individual that is not also at risk. And also a local or genetic counselor, just one, to inform you of the risks of pre-genetic testing, as well as after, to explain the results and help them if they need any support after that. And in conclusion, Huntington's disease is a rare fatal genetic, rare fatal degenerative disorder, and there's currently no treatment or cure for it. Huntington's and genetic testing can obviously impact your life. It can impact your health, your career, your finances, all of the above. And I had one question for you guys. Do you think that predictive genetic testing should be allowed based off of all these ethical issues and discrimination? Yeah.
Yeah, just based on the fact that like human choice.
Okay. Any questions?
So when you were looking into some of the